right, good afternoon, everyone. I want to thank you for coming back from lunch for a workshop session. We will try to make this as interesting as possible to keep you all awake and hopefully be informed. So my name is Jim Barton. I am a field engineer with Solo.io, and I want to welcome you to Mr. Toad's Wild Ride. Let me also introduce to my right here, this is Adam Sayah. He is the smart guy in this group, and so be sure and save all of the hard questions for him. We have about an hour and a half for this workshop, so we have time. And so if you have questions as we go along, no need to hold them until the end. Go ahead and raise your hand. We'll repeat them for the audience, and try to make this as interactive as we can. So you may think to yourself, why does this session have such a curious title, Mr. Toad's Wild Ride, and why? When I was a kid, I was 8 years old. My parents took me to Disneyland for the first time, and I was from the East Coast. Going to Disneyland in LA was a big deal. And so I remember lots of things from that day in my 8-year-old mind, right? There was, the Haunted Mansion and the Matterhorn and, right, all the things you do when you're at Disney. But the one ride that stuck with me the most was Mr. Toad's Wild Ride, because it was just this, sort of like a roller coaster, but not exactly. There was like something new around every corner. It's a really fun ride. In fact, it's one of the few rides that's actually been in existence since Disneyland opened in 1955. It's been refurbished a couple of times over the years, but it's still, my understanding is, it's still there, and new stuff right around every corner of the ride. And so when we were thinking about how to put this workshop together, there's a lot of material that we'd like to cover here with respect to how we can enable you to do GraphQL in an Envoy and Kubernetes context in a way that's fairly unique, we think. And so there's a lot of material we're going to cover. It's going to be very interactive. And so I invite you, if you have your laptop with you and you'd like to follow along, so there's a QR code there as well as a bit.ly link. Either one, they'll take you to the same place. But bit.ly/GraphQL-Toad, that will take you to an instruct workshop. In fact, I'm going to go ahead and kick mine off. The reason it's good to go ahead and kick that off now is because it actually takes a couple of minutes to provision the environment. So what's going to happen is everyone is going to have their own sandboxed environment that they can work through the elements of this workshop in. So if you don't have a laptop with you, or you don't want to follow along interactively, that's perfectly fine. You don't have to. Everything's going to be up here on the screen. But if you're like I am, you like to get your hands on and see what's actually going on, this is an option for you, and you'll have your own environment where you can walk through this stuff here. Okay, so that's going to take about a minute to spin up, and let's just talk. I'm trying to keep this, try to keep the slide content as limited as possible, but there are a couple of things I want to say just to set the context. Yeah, Adam? I should make it full screen. Thank you. There we go. So first of all, everything we're going to be talking about today with respect to our GraphQL deployment is going to be using Envoy proxy. Everyone in here familiar with Envoy proxy? Okay. Actually, okay, less than half. So let me say just a word about Envoy. Envoy is a reverse proxy technology, open source, that was created at Lyft back in the mid-2010s, open sourced in 2016, and you can see kind of their manifesto statement there at the top. The network should be transparent to applications. That's been their mission since day one. And so it has a number of important characteristics, a couple of which are really important for what we're talking about today with respect to making GraphQL easier to use in a gateway context. So it's completely open source, CNCF. It's actually a CNCF graduated project, very, very large community. You can see some of the community members on the right side of the screen there. And it came out of this realization that Lyft had back in the early 2010s that the world of software deployments had changed, right? It was no longer the case that you had a small number of monolithic stacks that you could do some fairly simple static routing across those big stacks, and that was good enough, right? The world was already changing into something that was more microservice driven, where there were a lot of interactions among much smaller components of software that were being reused across application areas. And so this realization led to the need for a new proxy, one that could handle things like ephemeral compute and automatic load balancing and service discovery and those sorts of things. And so Envoy Proxy came out of that environment. And there's some really interesting architectural elements of it that will be useful to us here. For example, you can see there's just a bullet there that says highly extensible. So what does that mean? Well, one of the primary mechanisms for extensibility with Envoy Proxy is that it's based on a filter chain architecture. And so what that means is you have a reverse proxy. Let's say it's sitting at the edge of your application network. You have a request come in, and you can configure that Envoy Proxy to pass that request through a number of filters before it's sent to the upstream service for processing. So for example, you might want to have it go through an external auth filter, right? So maybe it does an API key delegation, maybe it calls off to some identity provider. Maybe you want something like rate limiting that's applied to that. And so there's this library of open source filters that are available that you can plug in and configure using Envoy Proxy to configure those and to make that happen. And so this is just because of the architecture, because of the community around it, Envoy has really exploded in popularity over the past 7 years. And so you really see it being the foundation of a lot of the other innovations that are happening in this space right now, like, for example, service mesh platforms like Istio use Envoy Proxy as the foundational proxy layer that basically gets injected into all of the workloads that comprise the mesh. Okay, so that's where we're starting today. Is we're going to use Envoy Proxy, and we're going to see how we can apply that to make GraphQL architecture more interesting. So I'm going to do some gross oversimplifying here and try to do this fairly quickly so we can actually get to the meat of this. So a lot of what we see today with GraphQL architecture tends to look something like this. So there's a lot of effort that currently goes into building GraphQL server components, and there's a lot of typically imperative code that gets written in order to make that happen. And then often what we see is that there will be a second proxy layer that was perhaps already established in the organization that sits as a separate component from that. And so it creates an extra hop in the network. It creates extra configuration and extra management tasks and that sort of thing. And we think that perhaps there could be a better way. So what if you could do things like have GraphQL APIs that didn't require these dedicated servers? What if you could use existing API gateways in the organization to serve GraphQL just like you would with OpenAPI or gRPC or even things like SOAP? In other words, what if GraphQL were just another API and not this special sort of unicorn that requires its own special handling and feeding? What if you could use best DevOps practices like declarative configuration as a part of that gateway? Okay, so those are some of the questions that we're going to be answering today. And the way we're going to do that is we're actually going to show an architecture where we're going to bring together the proxy and the GraphQL service component into a single deployment. So basically using declarative configuration to configure a filter within an Envoy proxy that will then serve as our GraphQL server in essence. Okay, so we'll be able to treat GraphQL APIs in exactly the same way we treat REST APIs and gRPC APIs and that sort of thing. Okay, does that make sense? All right, very good. So there are a number of benefits of doing this in Envoy Proxy. Simplifying the deployment architecture, basically reducing the number of moving parts that are required in the service, sort of optimizing performance, right? We have fewer network hops to go through. Declarative configuration, you're going to see a good dose of that as we get to the interactive part of this exercise, where we're using declarative configuration to specify characteristics of our deployment. We'll also be able to leverage platform capabilities that come for free in the gateway proxy without having to do it ourselves inside of every single application. And we think that's an important benefit here. Okay, so in doing that, we're going to take a look at a handful of various service creation patterns and then how we can bring those together in this context. So the three we're going to look at today briefly: imperative, declarative, and generative. So imperative is pretty much what people have been doing with GraphQL since the beginning, where you're actually going to write code to implement a GraphQL API. So that's something that you can still do. It's fully supported. Declarative, where we're going to configure a GraphQL server declaratively in order to produce the API. That's a newer concept in my experience with GraphQL. And then we'll also talk about generating GraphQL APIs from existing resources, for example, like a gRPC service that might already be there, without that service having to be aware of the fact that it's being used in a GraphQL context. Okay? So those are the three concepts, and we're going to show how we can mix all of those together. Okay? If you'd like some more information about some of the how or some of the future of how those things are going to happen, particularly for the generative pattern. So Solo's CEO, Edith Levine, is going to be here on Thursday as part of one of the keynotes, and she's going to talk about using generative AI models with GraphQL. That's not something we're going to be showing today in this exercise, but it's definitely something that is on the horizon. Okay. So in terms of the how GraphQL gets added to Envoy proxy, as I said before, there's a library of filters that are available. A lot of them are open source with Envoy proxy, and so you can see things there like external auth and rate limiting and gRPC transcoding and so forth. Custom filters that you can build. You can build WASM-based components that basically do whatever you want. But one of the things that Solo has done here is to create a GraphQL filter, which essentially acts as a GraphQL server that you can configure with these declarative APIs in order to implement the service within the proxy itself. Again, just as you would any other API. If you're interested in the how of that, the actual design of it, there's going to be a session tomorrow with our lead GraphQL engineer at Solo, Sayah. He's going to be talking about some of the internals of how this actually happens, whereas today we're mostly just going to go through how to actually use it in practice. Okay, so here's what we're going to see on our ride today. First of all, we'll do some basic installation. We will show you a couple of different techniques for configuring GraphQL services. We'll show you declarative configuration as well as integrating with imperative configuration. We'll show you some schema stitching for pulling multiple services together. And then at the end, I'll come back and talk to you about how you can integrate just standard gateway capabilities that are part of the Glue product line and how they basically just work with in a GraphQL context now, which is pretty nice. There's no need for a special purpose gateway that just knows about GraphQL. Okay, so that's what we're going to be talking about. If you haven't already, if you came in late and you're interested in following along interactively, definitely crack open your laptop, go to that bit.ly link over there, bit.ly/GraphQL-Toad. You'll have to enter a little bit of information about yourself and then kick off the workshop, and that should eventually get you to something that looks like this. And so I'm going to go ahead, Adam, and turn it over to you, and we will start up the start up the workshop here. Is that big enough for everyone to see? We can make it, maybe that's a little better. All right.
Awesome. Hey, now let's put this in practice. Through this workshop, we're going to go through a couple exercises, and there's multiple labs. So it's going to give you a layout of this workshop. You're going to see instructions on your right and a terminal on your left. That mainly how we're going to interact with the workshop today. We're going to copy some content, some commands, and apply it in the terminal and see the results. So the way we're going to interact, after every lab, I'm going to just ask for a thumbs up to say, are you guys done with the lab? And we can move forward to the next step. And beside that, who is ready? You guys ready? Awesome. Let's go. So first step is to just install the right components. Our end goal here is to demonstrate how we can use Envoy as a GraphQL server. So first step for us here, just to install, let's have Envoy in our environments. Let's have some demo examples, and then we're gonna start using some configuration to test a couple things. All right, first step, you guys can go on the right side here, click on, you see the small icon here? If you click on it, it's gonna copy the code, then you can just go to your terminal and then apply it. And it should take a couple seconds. All right. Take a couple seconds for it to be ready. Let's take a look. Okay, so we see the components here getting installed. Okay, so we have multiple components here. Doesn't really matter. What's important for us is to know that we have Envoy now set up that we can use for as a GraphQL server. A quick question here. Who played around with like gateway capabilities in front of GraphQL, where it needs, for example, some sort of security or rate limiting or so on? Just by raise of hand. Okay, all right. So we see that basically this concerns, besides just creating the API itself, we are actually dealing with API gateway capabilities in terms of rate limiting and security and maybe masking certain data. So the first step here is just to get the GraphQL exposed, or actually creating the API through Envoy. At the end, we're going to see how we can integrate GraphQL gateway capabilities into GraphQL. All right. So the first step for us here, we installed, take a look here. We installed Envoy, okay? Behind the scene, it's Istio, right? Istio data plane, like mentioned earlier, is Envoy. This Envoy here has a baked-in GraphQL server. Okay, so right now we can navigate through the capabilities. I'm gonna take a look here, let's see if this is up. Not yet, I guess. Let's take a look. Okay. Seems running, but no. Interesting. Seems like my the UI is not running for some reason. All right, let's keep going here. So the first step, we installed Envoy. That's good. Let's keep going here and install some demo applications. All right, this is getting deployed. All right, we see the containers. So first step, we installed Envoy. That's good. Now, next step here, we are deploying this demo application that is, this kind of blog. It's a blog system where you can create a blog, you can create comments for it, and there's a certain users that are the one that's actually creating the blog and creating the comments. And we see the services running here. We see the blog on the comments, the user, and the user backup. We're going to get to this later. Who here uses like any GitOps approach to deploy configuration? Awesome. Who is familiar with GitOps concepts? Okay. So the way we think we should provide configuration to our environments believed in GitOps. GitOps is basically taking a declarative approach to your configuration. So you can create declaratively the expected behavior that your environment should do, and have a process that takes this configuration and deploys it on the cluster. The same way we think about it, like we're thinking about it for GraphQL. When you create a schema, a GraphQL schema, or you want to expose a certain GraphQL API, or you want to apply any sort of authentication or rating or so on, it's better to have it in a declarative manner in Git, and then have a process that takes this configuration and deploy it for you. So that's the best way to first have kind of a sort of through, like there is no configuration drift. You can have the same configuration as in Git always being deployed, and you can collaborate into modifying the configuration directly in Git. And also, if something fails or you want to roll back to a working state, you can just do, go back in Git and get to an older state. So this is an example of how we can use GitOps to deploy configuration to our clusters. Here, we are not going to use GitOps, but we are going to use manifests, right? But think about it that this kind of manifest can live in Git and get deployed on your cluster. All right, so the first manifest we are going to create, it's called, for us here, a route table, right? This manifest describes how the traffic is routed from the gateway down to your backend. In the first example, we're not going to use GraphQL yet. We're just going to show how traffic gets routed from the gateway, from Envoy, down to your backend service. All right. So I'll show you what I mean by declarative. If you take a look at this manifest, for example, yeah, route table. Let's think about this. Who here actually manage also like Kubernetes deployment of services? All right? Okay, so you guys familiar with this concept, right? In Kubernetes, you always have some sort of manifest to deploy the service, to deploy container, anything, right? Imagine your API living in the same repo as your application. So you create, for example, a REST service, right? You create a deployment for it, you create the service manifest for it, you deploy it. That's good. Then you have a REST service. But imagine in the same time, you can create a manifest within the same repo that not only, actually obviously you deploy your service, but not only that, you're also going to expose your service through the gateway. This is exactly what we're doing right now. We are creating this manifest alongside our application that describes the fact that we need to expose this REST service called /blogs, the blog service on /blogs, that is going to be exposed through the gateway. Another thing we are doing, we're also routing all the traffic to our UI here, the product UI called Glue Mesh UI that we are going to use for running GraphQL commands, but this is a detail. Here, what you need to understand is we are actually describing how the gateway, how we're routing traffic. When we go to our gateway/blogs, it's going to route all the traffic to the blog service. All right, so I already applied this configuration, so now it should work. So if I do this curl/blogs, you see, the curl/blogs is now working. So basically, our blog service is running on our cluster. I created this declarative configuration that routes traffic from my gateway to my blog service. All right, that's good. Now my UI also should be working because I'm routing it through the gateway. I have nothing yet deployed. I see I have a gateway, and it's not that important yet, but just to show that we're also routing the UI that we're going to use later for our testing. All right, so first step here was very basic. We showcased how we basically installed, we have Envoy running now on our cluster. We deployed certain Kubernetes services for demo purpose, and we also routed traffic from the gateway to one of the services. Now, next step is actually GraphQL. Now we're going to start talking about how we are going to create a GraphQL API using Glue Gateway, which is underneath is basically Envoy. Yes? Resolve block, I think Jim can probably help you there. Maybe you should just verify if the manifest got deployed. Actually, good question. Who here is done with the first lab? Oh, awesome. Very good. All right. Let's get started. Our first GraphQL API. So what we are going to do right now is this. We saw the concept of a route table in the previous lab. A route table, again, is the configuration that gets us the routing to something. And in the previous example, we routed directly to the backend service. Right now, we are going to do things differently. Now we are going to actually create a GraphQL schema and use the route table to route to it. That's just a kind of a configuration to tell the gateway to actually expose the GraphQL API. So here's the different configuration we are going to create. We are going to create a GraphQL schema manifest that is mapping certain resolvers to queries. We are going to create a resolver map. So basically, we are going to create our resolvers to get, to get the data from the data source. And we are going to create an API doc manifest, which is the schema itself described there. All right, so you saw that there is 3 configurations that we are going to create right now. The first one is the API doc. Right now, the previous example, we just exposed a REST service called blogs. The goal of this workshop, and actually this lab, is to convert this blogs REST service into a GraphQL API. So we are going to create an API doc for blogs that contains a query get blogs, and we are defining the type blogs, basically just saying it has an ID, it has certain content, and it has a title. Because if you remember, when we made the call to, I understand why it doesn't resolve to the IP. That's basically, you have to, there's like a command where it says IP equal, it catches the IP of the gateway. Yeah, in the previous lab. But if you guys remember, when we made the call, we had this JSON object, right? All right, so the first step, again, is to create the API doc. The second step for us is to create this GraphQL resolver map, where we are going to define our resolvers. And in this case, we are creating a resolver for the get blogs that is a REST resolver, right? So it is going to call our backend, which is the service blogs, right? And it will, get the path /blogs on that service. All right, and the last step is the GraphQL schema, where it maps this API doc manifest, where we had the schema there, with the resolvers that we just defined previously. So again, there's 3 objects to create. And the last step is modifying the route table. So we're going to modify the route table, so instead of going on /blogs on the REST service directly, this time we are going to execute, we're going to expose the GraphQL API that we just created. All right, so let's go and apply this couple manifests. There you go. Now we created all this configuration. It's time to test it. So if we go and grab, if we just do this curl command here, obviously you can use any tool to make the request for our GraphQL API. Right now we're just using curl, that's fine. You see we make the call here on the /GraphQL, which is the new API that we defined. We are passing the query, get blogs, with trying to get the ID and the content, and there you go, right? So again, you guys see that we used the gateway, we used Envoy, the same one that routes only a REST service, now created a GraphQL API for our blogs service. All right. Let's use the UI to make the same call, basically. I'm going to show you an easier way to do it. So now if you go and click on the Glue Platform UI on top there, now if you go under our APIs here, you're going to explore the API, define the settings, and let's get this one here. Oops, I don't need /GraphQL. And there you go. Oops.
So basically what Adam's showing right here is that this is an artifact that everyone's operating in their own sandbox, and so we're using a URL to basically get you into your specific sandbox and not into someone else's.
Yeah. Let me just double check on my configuration here. Where is the schema? Where's the query? There you go. So we go back to my UI. There you go. So again, we can use curl, that's fine, but obviously through this workshop we're going to do more complex things. It's better to use a tool for our GraphQL calls, and that's what we did right now. We just use the Glue platform to make a call. And you see here, again, to transform a routing to a REST server to a GraphQL API, the only thing we have to do is create our resolvers and define our schema. We didn't have to start a new GraphQL server. We didn't have to do some complex routing. The same Envoy process did both, right? They exposed our REST server and also created our GraphQL API. Okay, so let's keep going here, and let's start playing with more complex types. So right now, every blog has a user, right? Has a user that creates the specific blog. For this, we are going to modify our schema and to add this user type. And the user has a username. That's it, right? We're gonna get the info, the blog, from the blog, we're gonna get the users now. Let's go and apply this. Oops. There you go. And now, if I go to my UI and make a call again, there you go. We see now that we modify our get blogs query to not only return the primitive, types of the ID and the content, but this time we are actually returning the user that created the blog. And the only thing we have to do is just modify our schema to use users, to add this new parsing. And that's it. All right. Now, this is the first example, was mainly around how we have, let's say, we have one backend, let's say in our example here is the blog service, and how we converted that and created the GraphQL service for that backend. Yeah, GraphQL API for that backend. Now, let's talk about more complex things. And usually when you create a GraphQL API, we don't talk to only one backend service. It's often needed to go and make multiple, use multiple resolvers to go fetch data from multiple backends, right? So in our case here, we want to get the comments too, not only the blogs, but for every single blog, we want to go and fetch the comments. Now comments, it's a different service. If you guys remember, so we are using this blog service as a first backend for our REST resolver, but there's this comment service that is persisting the comments for a specific blog. So every blog has a list of comments from that service. Now, here's what we are going to do right now. We are going to create, modify our API to not only fetch the blogs, but also for each blog, we are going to fetch the comments. And here is how we are doing this. So we are modifying our API doc and adding this new type type comments that has an ID, a user, and the comment itself, right? And our type block now has this comment, this array of comments. And then we are all actually creating a GraphQL resolver map that is going to fetch, you see here, for the blogs, we are going to fetch the comments using the REST resolver here that goes to the comment service and execute this call, which is /comments with the block ID, right? So for every single call, when we're going to get the blogs, we're going to get the block ID, and then go and call this this comment service to get the comment for the block. All right, so let's apply this. This is applied. Now we can get to the query. So if I go back to my UI here, oops, I think I copied the wrong thing. Let's go back to the query quickly. There we go. All right, so you see now, I'm actually looking for the comments for my blogs. And there you go. You see, now not only we have the blog itself, we have the content, we have the user that created the blog, but we also have the comments linked to every specific blog with also the users that actually created the comments. Okay? And this is actually, kind of a common pattern here where we see obviously creating one GraphQL API that talks to multiple data sources to get something meaningful. All right. The last thing I want to show you here is transformations. How often do you guys see this actually in the real world where you're trying to fetch data from your backend, but the backend is returning a certain format that you want to transform it before exposing it to the client? Is that something common that you guys see? I see a couple yes. Yeah. Often we do not have control over the data that you get from our clients, right? From our backend. The backend will provide certain data. You want to expose to your client a certain way. You cannot go tell the backend to change the format. So this is why you need something in between that would transform the certain data with whatever you need. In our case here, what matters for us is that we want to have a word count, right? For our blog here, we are looking to provide a new data called word count that is not actually in our backend. Our backend do not return this result at all. The backend just returns the contents itself. So let's provide this capability. Let's use certain transformation here, where we are going to provide this new field called word count that counts obviously the words that we have in our content. And in here, the only thing we have to define is we are creating this new resolver, a type mock resolver, that is basically just using this function here to count the words we have. If we apply this, all right. Now we can use this new query, going back to my UI, and run. There you go. You see here? What we did right now, we modified data. We enhanced the data we got from the backend to add a new attribute that the clients can use without having to go back to the server and asking for any modifications. This is very powerful because I think this highlights one important thing that we're trying to showcase. The important thing is the gateway has a lot of capabilities in terms of transformation, security, anything you want. You want to use these capabilities alongside GraphQL because GraphQL at the end is just an API. So you can treat your API the same way. And in this case, we transform this data in the gateway before giving it back to the client. Yeah, that's a good idea. That's definitely a good question. That's the thing. You can do anything the long story short, yes. You can do anything you want at your GraphQL API, to your GraphQL API because you have full control since it's a gateway. And that's a common pattern in gateways is to enhance the response coming from the backend with some sort of like error handling. So the formatting and error codes. So for example, instead of getting like a 500, you transform to a 400 with a certain message for your front end to consume this. Definitely this applies also to GraphQL. It applies to GraphQL at different layers. The first layer is, let's say, all the query doesn't work for some reason. You can return a fake query or a mock query to say there is some bad data there that the front end can use, or at certain resolver, every single resolver, for example, that's going to go, let's say we did something wrong and we are going to fetch the blocks, and we get the block ID, and then we're going to go and look for comments, but for some reason, that specific ID creates a problem on the comment server, or there is no comments, or something happens there. You can tweak the response that come back from that resolver to say, if it's an empty list, do not throw an error, but shows just like an empty list. So from a processing of GraphQL, it will look fine, but you handled that kind of error not only to change the format, the response coming from the backend, but also change the behavior of how your GraphQL API behaves. So long story short, there's so many things in the gateway that you can do. Since the gateway, you have full control over the APIs. That's a good question. I'm not totally sure. I know that we have optimization for caching for sure, that out of the box, we cache the responses that goes to the backend. But for data loaders and going to like fetch multiple at once, that's not something I'm sure about. Huh? It's on the roadmap? All right, there you go. Okay, last one is, actually, I finished the transformation, so we're done with this lab. Thumbs up if you guys done with this lab here. Awesome, double thumbs up means like already ahead of the curve. Oh, you went all the way? Oh, I think it's just because the URL is not set. Here's I'll show you, I mean, probably he's gonna show you, but just for anyone that is in the same spot, I think what you have to tweak is this Explore API, go into settings, and I think this link here, you have to grab it from the workshop. It's one step that shows you how to set this link here. Yeah, so you go back to APIs, and then you go click on the API we are creating, then go to Explore API, and then go to Settings, and then there is this value that we provided during, like in the steps in the workshop. It shows you how to get this link, and just put it there. Okay.
Is there a way to refresh the introspection so that like those new things that we added when we applied those are actually showing that the Explorer documentation?
Yes, the problem is I'm using a bit of an older version here, but that's definitely something. Yeah. Okay. All right, let's keep going here. The next step is I'm going to do some remote execution and schema stitching. Okay? Here's the thing. I showed you in the first second lab, that we can create in the gateway, we can create GraphQL APIs that goes and talk to multiple data sources and show and export the gateway itself. But at companies, we see often that that's part of something, a solution, but not everything. We see that there's a lot of companies that have multiple teams that already own some GraphQL servers, and so on. And their main goal is to either provide secure standardize their API exposition to the front end, and also maybe they just want to do schema stitching between multiple GraphQL schemas that they already have, right? So in this example, in this lab, we already have this schema that we created that fetches the blogs and the comments, and we have the user section that has only username. What if I want to enhance this username to go and call another GraphQL API that already exists in my system to get, let's say, the name and like the first name and last name of the specific user based on just his username, right? So we are going to show schema stitching. I'm pretty sure everyone's familiar. Who's familiar with schema stitching here? All right, everyone, cool. Alrighty, so here is the first part of the lab is creating a schema that talks that we are going to do a remote execution. So basically, talking to an already existing GraphQL server that you have. Here, we're defining this new schema that is fetching the users. The type is user, you have a certain ID, we have your username, last name, and the first name. And we're defining a query gets user details, passing a username, we get a user. Then in our GraphQL schema here, we are, instead of previously we had the GraphQL schema linking a certain resolver map with a schema. In this case, we are actually defining that is a proxy call. And here is the GraphQL server. For this specific schema query, we'll go and look at an existing GraphQL API. So after creating these two resources, now I can go to my UI again, back to APIs, here, APIs, explore the API. This time I can run this query, which is get user details, and there you go. So this call here is actually going the GraphQL call I made right now is actually going to this server here called users, okay? This service users is actually a GraphQL API, GraphQL server, right? So imagine this is already something existing in your company that's already exposing a GraphQL API. What I did right now, I just created the schema in front of it. So when I made this call, get user detail, I went all the way to my backend server, which is a GraphQL server, and executed this call. Why is it important to do this? Well, first, we are standardizing around the gateway, right? Our main goal, and I hope I highlighted this during this workshop, is that the gateway is the way you're exposing your API to your frontend, right? The gateway is responsible for security, for standardizing the API, doing certain transformations and so on. So having also a way to declare how the proxy call, even for existing API, is important. And we're going to see how we are going to use it now. Now, let's actually enhance the first, you remember the first schema we created that has only the user section with username? What if we stitch the two together? The first one just provides the username for a certain comment or a certain block. The second schema here, and that's the one that goes all the way down to my GraphQL server, has this get user detail that passing username would get the full detail, right? And our goal is, through my UI, I want to create this stitch schema that shows the content of my blogs, shows the comments, and also get me all the details for my user. All right. So let's do it. what we are going to define now is a GraphQL stitch schema. It's going to stitch the blog GraphQL API that we created in previous labs with this user schema that is the proxied one that goes to the existing GraphQL server. And in the type merge here, we're defining a type merge to say, for my user type, grab the username, execute the query, get user details. Okay, we're passing that as an argument for get user details. And that's it. We are going to modify the route table. Route table, again, remember, that's the first configuration we saw, is the routing at the gateway level. The route table we are modifying this time, it's just to say, instead of like, previously we were routing to just the user schema, now we are routing to this stitch schema. Okay, that's it. So let's go and apply this configuration. And there you go. Now if I make a call back to my UI, let's go and run this query. There you go. Now we have a full GraphQL API that not only we created the GraphQL server, GraphQL API for a REST server that existed on my environment, but we also stitched this schema with an existing GraphQL API. And here we have a full data all the way down from the content of the blog, the comments, the user that created the blog, the user that actually created the comment, and so on. So you see, using the gateway, we provided the GraphQL capabilities. But this is just half of it. That's just creating the API. Another aspect of a gateway is security. And that's basically what we're going to see right now.
All right, very good. So thank you, Adam. So that takes us through to the last exercise here. And in this last exercise, we're going to take the existing GraphQL services that we've stitched together, and we're going to show you just how to apply just some basic gateway capabilities that are really independent of GraphQL. Okay, so these are just things that we get in essence that we get for free by virtue of the fact that we're using this Envoy-based gateway technology, and it works with GraphQL just like it works with REST, just like it works with gRPC, just like it works with other technologies like SOAP and so forth. So, let's explore some of these other features that we're going to use to harden our GraphQL API. So we're going to look at 3 in this context. The first thing we're going to do is just a very simple, we're going to apply API key security through the gateway that's going to protect this GraphQL service that we have that we've created. So there's a whole laundry list of different security techniques that are available. You can kind of see on the left nav there. You can see some of the different techniques that are available to us. We're just going to do simple API key for this example, but we could do any of these others as well. So what we're going to do is we're going to create first. We're going to create in Kubernetes. We're going to create a secret here that we're going to specify an API key. It's going to have some metadata associated with it. We'll store that here in Kubernetes. We are going to define something called an XDauth policy. So this policy, again, declarative configuration that we can apply to any of these routes that we have created, whether they're using GraphQL or whether they're using some other technology. So with this external auth policy, you can see we're going to apply that to any any route here that has a label called secured with a value of true. So anywhere we see that label, this policy is going to be applied to that. And then we're going to basically say we're going to take these. We're going to apply this API key policy to that. Okay. And so then the other thing we're going to do here is we're going to modify our route table to simply add this label that's going to cause that policy to select that particular route table. Okay, so that's all there is. That's all there is to it. So we have. Let's go ahead and we will create our sample API key here, and then we're going to create the external auth policy that's going to basically define that policy to any route that has a particular label, and then we're going to add that label to the route table so that that policy will be attached to it. Okay, so let's apply the route table change. And once that's done, now we have added, again, through declarative configuration, independent, right? The application itself knows nothing about any of this, right? We didn't do anything to the underlying applications. We're simply declaring this to the gateway, and it's being applied via our Envoy proxy at the edge of our application network. So now if we go back and we try to run this same query that we had before that worked just fine a moment ago, what you're going to see is that's going to fail now because we don't have, initially, we don't have that API key attached to it. So let's go ahead and run this. When we do, you're going to see we get back an error message here. So then if we go in and actually apply the API key as a request header, so you can see here's the syntax here. So we will add that via this little graphical browser here. Be sure if you're following along, don't put it in query variables. That won't work. Put it in request headers. We'll apply that API key, and now when we do that, we rerun the query. Now it's going to work just like it did before. Okay. So again, we're trying to move this sort of infrastructure definition away from the service itself. Right, these kinds of platform concerns away from the service itself, and do this in the external networking infrastructure. Okay, so that's a very simple example of applying API key authentication. Now let's take a look at another common. All right, API keys. Here we go. So two more we're going to show here. One is we're going to show you an example of query safe listing, a very common technique, right, in the GraphQL community for reducing the available attack surface to get at GraphQL services, right? So let's say we're in a production environment, and we want to say, okay, in this production environment, we only have this subset of, let's say a dozen queries that we want to allow. And so by specifying a query safe list, we can ensure that anything that doesn't match those well understood dozen patterns is going to be rejected. So so to do that, there's another API we're going to introduce here called a GraphQL allowed query policy. So we can declare that, and we'll basically say, apply that to any of these routes that has this label secured true, and then these are the query hashes that we're going to allow to be applied via this policy. So basically, trust me, we go in, we take the query, we generate the hash from it using a service like this, and then we can apply that hash with this policy and attach that to the route. And when we do that, then only that particular query string is going to work. So if we go back here and we run this same query, that is acceptable, right, it should still work, okay? So that's still fine. But let's say we go in and we try to change something, right? So, a malicious actor comes in, tries to inject a different query into our system. Let's say instead of getting the ID, they try to get the title, right? So that's going to change the hash of this query. We run that again, and now we're going to get back an error that says, sorry, that hash wasn't found. It's not in the allow list. Therefore, this query is rejected. So really easy way to reduce the attack surface of your GraphQL systems at the gateway level, again, without involving the underlying applications at all. Okay, does that make sense? All right, very good. One more thing I want to show you here really quickly, and okay, safe listing, okay. So let's talk about data loss prevention. And there are a dozen things we could have shown in this context, but just trying to get a kind of a sample of various techniques that you can apply at the gateway level via declarative policies applied with Envoy. And so here's one. So data loss prevention API here basically allows you to do things. Let's say there's some sensitive information in that your services are returning, and what you'd like to do is you'd like to be able to mask that sensitive information. So, for example, right, you have let's say social security number is something that's managed in your application. When you report that back to an end user, you only want to show the last 4 digits, and you want to obscure the first part of that, right? So we're going to follow an example sort of like that. What we're going to assume here is that the username that we're passing back to the user, we're going to say that's sensitive information. We don't want to expose that entire username because it's bad, PII. We don't want to expose that. And so what we're going to do is we're going to create this policy that says, essentially, look for a regular expression that includes username in the output, and then transform that response to use this masking character over 60% of the body of that string. Okay, so there are more sophisticated policies we could apply, but just to give you the idea. So we're going to take that policy, and let's go ahead and apply the policy itself. And then what we're going to do is we're going to update the route policy to update the route table to attach this label so that the policy will select that route and it'll be applied. So very much like what we did before. So let's go ahead and we'll change the route table. And so now, what do we expect to happen if we go back and we execute exactly this same query that we had before? Oh, I need to change, exactly, yep, yeah. Well, that's good. See, we can mix in these behaviors, right? They're all working together. The query safe listing policy is still applied. But yeah, if we go back and we change that back to the acceptable form of the query, there you can see it works just fine, and there you can see anywhere we see a username that 60% of the characters are being obscured. So again, without touching without the application having to know any of this stuff, we're able to apply these policies at the edge of the network in a declarative fashion. Okay, so that brings us to the end of the workshop piece of this. If anyone has any questions right now, I'll be happy to take that, and then just have one more thing for you here, and we will call it a session. Any questions that Adam and I can answer for you? Okay. If I understand the question right, you're asking if via these policies we can apply additional transformations? Yeah. Yeah, absolutely. I'm not going to try to create an example for you here on the fly, but the short answer is yes. You can absolutely create there's an entire pretty sophisticated library of transformation policies that are part of the Glue product line that have actually been around for years. And you can do, there's scripting languages that are built into it, like JQ templating, that sort of thing, as well as just sort of standard, standard sort of transform. So yeah, you're pretty much limited just by your imagination there. I'm sorry, could you repeat that? Did you hear that, Adam?
Yeah.
Yeah.
We have a similar example that we see that a lot often used is rate limiting, where when you get rate limited a certain amount, instead of 429, you just say, hey, wait a couple minutes before making a call again. Exact same use case. If you can say, if you see a 403, then instead of just returning, hey, like a no error, like a authorize or whatever, you can say, hey, you're not authenticated to make this call. So you can do whatever you want.
In fact, I'm pretty sure in the docs there's actually a specific example around that use case. Yeah, you could definitely do that. Question? Yeah.
Yeah, so who do you usually see owning the definition of these CRDs? So is it ops, front end, back end?
That's a great question, and I think that's a bigger question than just a like a solo question. I think the issues around governance of schema and so forth, I think that's something that the community is still answering. So I'm not sure, based on our experience with our customers, I'm not sure we have the definitive answer for that. I mean, I definitely see organizations that are creating governance groups where there are multiple stakeholders, especially, more sophisticated organizations where you'll see, governance organizations where, multiple stakeholders are determining those things. Yeah, definitely what we're trying to do here is to provide a way that you can, however those policies and so forth are determined, that you have a way that you can apply those, in a single control plane, and then have those reliably managed around the edge of the network, however you develop the policy. We're kind of agnostic on how the policies are developed, but we're very opinionated about the fact that you should be able to define them in a declarative fashion and have them pushed out to multiple policy enforcement points, even around multiple clusters in a network.
If you see often in big companies, there's different personas that own parts of the system. You see, for example, we have the platform engineer that owns the gateway capable, the gateway itself, the infrastructure part. Then you see a security engineer that owns the policies around, I don't know, rate limiting, authentication, whatever. And then you have the developer, obviously, and sometimes you have an API developer. That's the one that packages the APIs, either from like a REST perspective through a portal, you can create API products, so on. So in this case, just to Jim's point, it's flexible to have multiple personas operating this.
Yep.
So you can have like an API doc or the dev team owning just, as you saw, the GraphQL schema. But in terms of security, he created the schema, but there's another security guy that just goes and manages the security policy.
Yep.
And all the component just ends up in being enforced in the gateway, which is essential component. So that's a long story to say it's completely flexible. There is certain, we see certain personas sometimes in big, large companies owning these different components, but there are startups that own everything too.
Yep, good stuff. Yes, sir.
A great question about creating actions.
Mm-hmm.
So if you enable that feature,
Yes.
if you want to create something else.
Yes. Yeah, so just to be clear, with respect to query hashing and safe listing queries, I would not recommend turning that on in your development server. Yeah, that could have some really nasty consequences. So yeah, we envision that as something that's an extra security layer that you would apply, potentially, definitely at a production level, maybe at one of your higher level service layers. But yeah, you want to keep that far away from your development servers. I'm sorry, could you? Exactly, right. As you get to higher levels of, higher staging environments in production, right, then it's like, okay, no one should be experimenting, right, in this environment. Therefore, we're going to lock that down, and we're only testing or putting into production things that, that we know, right? So, yeah. Good observation there. All right. Anyone else? Yes. Yes. Right. Okay. Yeah. What's going on? Okay. I know where you're headed with that question. So when you're looking at the UI, the graphical explorer, it's trying to interpret when the response comes back, it's trying to interpret that as JSON. And when it tries to interpret that as JSON, it's not when it's an error message. And so it's getting confused, and it's displaying that sort of non-intuitive error message. If you did it through something like curl, right, where you're curling that endpoint, then you would get back a proper, like a proper, say a 403 kind of response, something like that, that would indicate, right, it's an artifact of the fact that we're using this UI to, so yeah, but yeah, I agree, it is counterintuitive, yeah. The performance impacts of query safe listing? It's a good question. I don't think there wouldn't be any negative performance implication at all. I mean, it's just something, it's basically a condition that's going to be applied in the Envoy filter at the edge of the network. And so if anything, I think it would have a good impact on performance from this, as compared to if you're doing something back in the application service itself. Right, I think there might be additional layers that you would have to go through to get to that, depending on how. So basically, what's happening here is we're going to intercept that call at the at the gateway layer, right? And the gateway is going to say, okay, that's not right. Here's my list of acceptable hashes. That's not in the list, and you're done, right? There's no additional processing. That request would never get past the gateway. Yeah.
You can think about that like a rate limiting, right? Adding maybe a tiny aspect to your gateway, but you're protecting from the larger attack, which is really going to bring down your system. So.
Yeah. Yeah, good questions.
I guess one. So on the stitching part?
Yes.
What if the other side requires authentication?
So authentication has like just...
let's say the REST API requires
Yeah.
Yeah, so you can pass any type of headers.
Yeah.
So on the gateway side of it, that's where you have to configure, or outside before they get it?
So you get the query through the gateway, then the gateway will make this call to the GraphQL server, the proxy one, and you can control what you're passing there.
Yep.
An API key, next to a header, a barrier token, whatever. Yeah, that level. So basically, it's in between. So your gateway, between your gateway and your backend server.
And you can obviously have different authentication strategies in place across different upstream services, and it'll allow you to rationalize those. Yep. Yes. Very good question. Okay, so recommendations for monitoring. So Envoy Proxy has been around for, since 2017 in open source form. One of the principles of Envoy is providing superior metrics and providing a platform where metrics publication is an easy thing to do. So there's a ton of metrics that come just out of the box with Envoy that you get just because you plug it in there, right? There are also some specific things that we publish out that are GraphQL related that we just add into that metric stream that you can consume. Now, in terms of how you consume that, we're very agnostic about that. So we support OpenTelemetry, for example, as a standard. So you can you can dump all these metrics out to an open telemetry stream, and you can consume them with whatever. I mean, we really, you know, our goal is to not be involved in that decision for you. We give you the basic platform that allows you to publish things the way you want, and then you can consume them with, you know, Datadog, Splunk, New Relic, right? We don't really care. Yeah, good question. All right, good lively interactions. All right, anything else? Yeah, sure.
GraphQL syntax highlighting those YAML files, is there like tools for that? When you're editing SDL in those,
That sounds like a roadmap item. What do you think, Keith? Yeah, yeah. I mean, you're definitely free to use other tooling. You know, our focus is more on providing you the, you know, the infrastructure to specify things in a way that is declarative and repeatable and that sort of thing. We've done obviously some investment on the UI side, but I would say that's not our forte at Solo. And so, yeah, whatever tools you would use typically to do that sort of, you know, schema editing and that sort of thing, I would say continue to use those, and you know, and we'll provide you the infrastructure that allows you to manage it in a, you know, in a solid, repeatable fashion. Yeah. Good questions. All right. I don't see any other hands at this point. Let me offer you a couple of ideas. Yes, sir.
That was a great question. I'm just kind of curious, like, since we're in the interactive mode now, what people use, like, we use internally, we end up just using, like, VS Code, which does plenty of, like, syntax highlighting, and code snippets and everything like that for SDL editing. Just curious if, you know, from an audience perspective, are there other tools that people use that they highly recommend for that?
Did everyone hear? This is Keith Babbo. He's a director of product at Solo. Yeah. So he's asking about what are your favorite tools that include things like syntax highlighting and that sort of thing for managing GraphQL schema and other artifacts. Yeah.
lots of linting type tools, right?
Okay.
For your schema and making sure that the conventions are being followed for whatever reason.
Yep.
I mean, if my head has been turning around how I would do that in this approach with
Mm-hmm.
declarative, and the schema spread out on all these
Yeah.
these definition files and how I would run linting across those within YAML. But yeah, ESLint has
Yeah.
forms for GraphQL stuff. I mean,
Yeah.
VS Code has your extensions that you can annotate.
Right.
Hey, this is a string, but it's a GraphQL string, so like add syntax highlighting. Because I mean, GraphQL syntax is the same as the programming language you're working with, like
Yeah.
JavaScript, so it can be highlighted individually
Right.
in the context of a file. But,
I heard VI is
VI is awesome. I'm,
GraphQL Inspector is a great tool for the build, by the way. Like, and we use that to recommend to customers a lot. If they integrate with, like, automated deployment pipelines and this type of thing, it's fantastic for that. Mainly just around, like, SDL is pretty compact and straightforward to specify. And so, like, when we talk to folks about, like, what is the, like, if they want design type tooling or creational editing tool for SDL, like, you know, what they're looking for there and how can that experience be improved. Because, like you said, most top text editors that people use provide a lot of, like, templating, code snippets, this type of thing, and validation that you just have right out of the box in the text editor you're already using. So for us, from a roadmap standpoint, we realize it's kind of a religious area for most devs.
Yeah,
What
yeah.
editor they're using.
Yeah.
And so we're kind of said, like, we stayed out of that, but if there, in the community in general, if there's an opinion on, like, hey, we really want a visual tool to do this, or these are additional things that VS Code and other tools are not solving right now, we'd love to hear that and contribute those things.
could you push any of that into a file and then like load that from a volume, like separate it from the YAML and like define that in the .GraphQL file and then like load it into like a volume
Like what you
output?
want to look for, like if you use like semantic checks and that kind of thing, or like.
Yeah, or if you made a syntax error when you're writing SDL, when you go to apply that YAML, is that when you're going to see the error, or are you going to see that like in runtime when you?
So we're big on GitOps and just continuous delivery and DevOps practices in general. So like our whole flow is our APIs and Kubernetes custom resources, basically. And before you get there, you're actually committing that SDL into Git and like associated custom resources for us. And then you have a pipeline that's deploying them. In that pipeline, we recommend running something like a GraphQL inspector that absolutely will validate and do any sort of
Yeah.
another thing is like in Kubernetes, you can have a lot of concept like a validation webhook, right? Like the same thing when you create a deployment that is wrong, or a service that's gonna collide with something else. You're gonna send this, the manifest is gonna go to backend server that can get validated before persistence. So alongside what Keith is saying, that's also something that the GraphQL, like even for us, that can be like in the server before persistence, before persisting the GraphQL schema. We do the verification. If everything's good, we get it in.
Yep, good discussion. So we're almost at time here, and I want to respect that there may be someone coming in here after this for to do another session. So if you'd like to continue the conversation, obviously Adam and I and Keith would love to chat with you afterwards. Some other opportunities for you as well. So Solo has 3 additional conference sessions after this one. One is actually Keith presenting tomorrow during the keynotes. I think I mentioned Sayah's presentation tomorrow afternoon. He's the lead engineer on GraphQL at Solo and has a lot of great insights into how and why design decisions were made and how this works and so forth. And then also Solo's CEO, Edith Levine, is going to speak during the Thursday keynote sessions to talk about generative AI models with GraphQL. So those are some additional opportunities. Also, we're going to be in the showcase, sponsor showcase, booth P1. I understand it's right at the front of the room, so you can't miss us. And also encourage you to check out Solo Academy. If some of these gateway concepts especially are newer to you, there's a ton of great resources at academy.solo.io that will help you understand what we do both from a gateway standpoint as well as specifically how we layer GraphQL functionality into that. So I want to thank you all very much for your time. Your interaction was absolutely superb, and hope you enjoy the rest of the conference.